Hi, hello everyone. Good evening. This is your Ameer sir, Master Teacher of Physics at Vedantu. And a very warm welcome to another amazing session of Rapid Sprint 2.0. Okay, when I said super amazing, it's your also responsibility to make it super amazing, isn't it? Because we both have the same responsibility to make the session super great. So yes, hi Meda, good evening and good evening to each and every one in the classroom again. Okay, so tell me how was the day for everyone and how are you all doing? Are you all doing good? Are you all doing good? I'm gonna think that yes, you all had a wonderful day, just like me because for me it was I don't know, no particular reason was there, but it was super good for me. So I think you also had a super amazing day and it'll be good if I can listen the same from you. So you can start responding in the chat box and make it so lively. And what about your revision? How is it going on? What about your revision plans? Obviously, it'll be going good because you all are with me, and together we are doing the sprint series, and we have almost reached the very last chapter of the first part of physics, right? Which is EM waves. And EM waves, you know that it's a very chotu chapter. Okay, let's say I'm not telling there's 100% of surety of a question coming from EM waves. Okay, let's say almost 60 to 70% is there, but if a question comes, you must be well prepared, right? So I'm gonna make sure that okay, or let's make sure that okay, whenever a question pop ups, you're gonna write it. So I have taken some very serious and very important question from the same chapter, and we are going to discuss it together. So that okay, you are going, which means the questions are chosen in such a way that we are going to cover the entire theory of this particular chapter. Okay, and we'll also be solving the problems. And most of the problems that I have chosen is from the previous year question papers, so you can understand the level of the question also that pop-ups from this particular chapter. Okay, so I hope everyone is doing good and everyone is ready. So before that, you can also see the list of chapters which is being completed both by me and Gaurang sir, right? So here we are at the end of this month, which is now we are going to take EM waves, okay? And today at 9 o'clock, Gaurang sir will be taking electrostatics. So if any one of you have missed any of the sessions, now itself move back. Okay, after the class, you can type in whichever chapter you want in our channel, which is Momentum with Vedantu, and do that chapter because we have done so many amazing questions. I don't think you want to miss that. And one more thing, it is regarding the subscription, right? Because why we have to ask you for do the subscription? It's simply because okay, we don't want any one of you to miss the amazing videos which we are uploading here, okay, which is going to be super useful for every one of you because you all are preparing for the JEE, and we are focusing on that right now, and so many videos and so many classes are happening. So don't miss that. So don't be lazy. Now itself, move your cursor and get it subscribed. And one more thing, we have our official Telegram group, which is Momentum with Vedantu. In this channel, we will be uploading, right, all the question, whatever we discuss here before we actually discuss it in the classroom, which means before this live session happens, the questions will be uploaded here. So before you come to the classroom, you can also have a look at it and you can understand which all are the question which is going to come and we can discuss it together in the class. Okay, so will that be amazing? Yes, it's going to be amazing. And one last thing, after this, straightly, we are moving into our session. What is it? It is about the crash course which is being happening in Vedantu for JEE and NEET 2021. Because we want every one of you to crack both of the exam. If any one of you are seriously preparing for it, you can come and join here. Right? Why I say that though the sprint series is going on, the crash course is going to be super awesome because here we are going to give you a personal mentoring, which means personally we are going to help you to make a timetable for the upcoming exams. According to the timetable, we are going to take classes, which means entire theory will be covered. Okay, and not only just the theory, along with that, we are going to make you do so many questions from the topic. Okay, previous year questions, and what else in the class itself, all your doubts can be cleared because nowadays you'll be struggling to clear your doubts, right? And all your doubts will be cleared. Then what else you want? Yes, don't you want to analyze what all topics you have learned and how much you have learned, right? You need to write the mock test. So we are providing the mock test, and all India level rank list will also be provided. What else you need? Okay, and what is going to stop you from coming and joining for this crash course? Nothing should be, right? So now itself the description is given. Okay, so the link is given in the description. I'm sorry for that. Okay, the link is given. Click on the link. Okay, apply the coupon code. After applying the coupon code, instead of Giving 10,000, you will be getting just for 8,000, and you can enjoy an amazing session with the Vedantu family. So I hope we are going to meet in the real classroom. So that's it. It's time for the very first question. Shall we start? Are you all there? Every one of you. Shall we start? Okay, so here we go with the very first question for the day. What is it? Okay, in an electromagnetic wave in free space, the RMS value for the electric field is 3 watt per meter. Okay, the peak value for the magnetic field is, we know that in electromagnetic wave, it composes the electric wave and the magnetic wave which are perpendicular to each other, right? Okay, now the RMS value, what is RMS value? RMS is having a form of root mean square, which means it is a form of taking an average of the electric field which is having a varying value, right? It is having because you know that the electric field is having a sinusoidal wave like this, so it keeps on changing its value. So the RMS value, the average value of this electric field is given as, so E RMS is equal to 3. Okay, how can we find out the peak value of the electric field? Now you have to know the relationship between RMS and the peak value, right? So E RMS is calculated as maximum value. E naught means the maximum value, which means this is the maximum value for the wave, right? That is E naught divided by root. Okay, now if you want to get the maximum value of electric field, that is root 2 times ERMS. So that is root 2 times, what is the RMS value for electric field? That is 3. So E naught, the maximum value of electric field, we got it. But was that our question? Not at all. What is our question, everyone? Tell me. It is to find out the magnetic field. Now, in an electromagnetic wave, which is the equation that connects the electric field and the magnetic field? The magnetic field B naught is equal to, what is it? B naught is equal to E naught divided by C. So E naught is 3 root 2. And what is the C? Should I have to actually mention for a student of 11th or 12th? It is the speed of light. What is its value? It is 3 into 10 power 8. Yes, 3 cancels, right? Root 2 is 1.4 into 10 power 8. If it comes up, 10 power minus 8. And this is magnetic field. So what is the unit of magnetic field? It's Tesla. And root 2 is 1.414. So which option we can go for? We can go with the option A as the answer. Any doubt in this? Anyone in the classroom? If you have any doubts, now itself express whatever your doubt is. We're going to get it cleared before we proceed to the next. So if you're going to respond within 5 seconds, I'm going to think no doubts are there with anyone, and we are going to proceed to the next in 5, 4, 3, 2, 1. So let's proceed to the very next question. What is it? Okay, so in a plane, hi Prasanna, good evening. Okay, happy to see you. Join the class. Okay, this is the second question. Okay, you can also answer before me giving me the answer. Everyone in the classroom can do that, right? A plane electromagnetic wave travels in free space along the x direction, right? Okay, the electric field component of the wave at a particular point of space and time is, the value for electric field is given, and the electric field is in the y direction, which means the electrical wave is making its motion in the y direction. The the electromagnetic wave itself is moving in which direction? In the x direction. So here also the question is about magnetic field. You might be thinking, isn't it the same question? No, here we have to specify the direction of the magnetic field. Okay, how is it possible? So Jatin already says it's option C. Let's see whether the option which is given by Jatin is correct or wrong. Everyone can respond. Okay, hi, good evening, Vijay. So the same formula it holds in finding out the value for magnetic field. What is the formula? E naught by C for finding out the magnetic field maximum value in an electromagnetic wave. Right? What is E naught? That is given as 6, and C is equal to 3 into 10 power 8, which is velocity of light. This is 2 into 10 power minus 8 with Tesla. Okay, now we have to understand in which direction is this magnetic field is having its variation, or in which direction the magnetic wave is present. Now you have to know this, right? The electric wave and the magnetic wave are perpendicular to each other and perpendicular to the direction of propagation of the wave. So electric wave is in y direction, the electromagnetic wave together is moving in the x direction, so which is the only direction left for the magnetic wave, okay, to perpendicular to be both of them. Okay, which direction is left? It is the Z direction. Yes or no? So this magnetic field of 2 into 10 power 8 Tesla will be in the Z direction. So it is option D. Okay, so sorry. It is option C. It is option C itself, right? Okay, sorry. So I was just confused. Yes, we're gonna do Prasanna. Don't worry. Okay, maybe because in Feb, we are going to have the JEE Mains exam, right? Maybe till then, I might be simply continuing with this. After that, it's a sure thing. Okay, like I promised, because I want to keep my word. Like I promised to everyone. After that, we're gonna start with the board theory. One shot of theory will be done. 1 hour class. Okay, one chapter we'll be doing in a day, and we're gonna complete the theoretical class of each and every chapter. It's sure. Yes, we are doing this mains question. Yes, Palki. Yes, we are doing whatever the questions are. These are the questions which has a greater probability for coming for the JEE Mains. So just stay with me till the end. We are going to cover the entire topic of EM waves by doing as many questions as possible. So are you all ready for the very next question? Are you all ready for that? Prasanna, Jatin, Palki, everyone in the classroom, Vijay, is it a yes? Okay, very good. So here we go. Now, 50 watt per meter square. So what is this 50 watt per meter square? What is the unit of power? Right? Power is equal to energy by time. So what is energy by time? By meter square means it is area. Energy per unit area per unit time. This is called as intensity. So the value of incoming intensity of the sunlight is given as 50. So the intensity of the incoming sunlight is given as 50. Right? Okay, fine. It is normally incident on the surface of a solar panel. So before continuing with the question, let me tell you this. I hope you all learned the dual nature chapter, right? In that we have, or we are learning that the light is what? The light is not only an electromagnetic wave, right? It is also associated with what? Yes, the particle nature, right? So if light is considered to be a particle, and if it is coming and getting incident on a solar panel, a particle, what can it exert? Yes, a momentum on the surface, and this change in momentum is going to produce a force. So obviously, when a sunlight falls on a surface, it is going to produce a force on the surface, right? And the formula for the force experienced, okay, by the surface, if the light is getting reflected, is given by 2I by C. Okay, I is the intensity, C is the speed of light, and the amount of force experienced by the surface, right? If the light is completely getting absorbed, is I by C. Okay, these are the two formulas. We are not doing the derivations here. It is not so important, but this equation is important. Okay, with regarding to JEE Mains and NEET. If those who haven't learned this equation, please do write it in a book now itself. Don't waste your time now itself. Please note it down. Okay, this is for reflective. If the light is getting reflected, if this is when the light is getting absorbed, the equation. Fine. Okay. Now it says that some part of the incident, 25% is reflected. So from the total I, 25% of I is reflected and the remaining 75% is absorbed. Right? So the total force experienced, the total force exerted. Okay, how will you find this out? It's very simple. So force is equal to, it is I by C or 2I by C. But this light which is coming and getting incident on the solar panel, a mixture of phenomenon is happening, which means 25% of the intensity, that is 25% of the intensity is undergoing reflection. So the amount of force is equal to 2I by C. Okay, not the entire intensity, only 25 by 100. So that's why 25 by 100 into 2I by C, and the remaining 75 by 100 of light is completely getting absorbed. So the amount of force it gives is equal to I by C, not the entire intensity. 75 by 100 of intensity is giving the force because of absorption. So the total force is the summation of this. Is it clear? Is it clear to this part? Okay, now let's do the mathematics. 25 into 2, that's 100, plus 75, that is equal to 125, right? 50 plus 75, 125 by 100 into I by C. Yes or no? So let's start substituting the value. 125 by 100. What is the intensity? That is 50 divided by 3 into 10 power 8. Okay, so obviously the unit is in Newton, right? And how much is this value going to be? It is going to be having a value of 20.8 into 10 power minus 8. How much it is? Yes, 20.8 into 10 power minus 8 is going to be the answer. So we have learned a lot. Are you all happy till this part wherever we have covered? Understood all the concepts? Everyone, please be responsive. Please be active in the class and let me know your answer. Is it clear till this part? Because this is a part or this is a concept which we have covered not from the NCERT topic, okay, which means from other than the NCERT topics, which means this is has a greater probability for coming for JEE and NEET. That's why we have discussed it here. Okay, so just like the channel says, Momentum with Vedantu, yes, you all are learning a lot and we have yet more to learn from the topic. So I think it's a go for the next topic or the next question. Sorry. Now it's a very simple question. Can I wait for everyone to give me the answer for this? During the propagation of electromagnetic waves in a medium, we know that we have electrical energy, right? We have the magnetic energy. The energy per unit volume is electric energy density and magnetic energy density. So how is it going to be? Okay, or which option regarding this electrical energy density and magnetic energy density is going to be true? Which one? Every one of you tell me. It's a very simple thing, right? You know that the total energy is which is carried by the electromagnetic wave is stored totally in the electric field and the magnetic field, right? And this energy will be equally divided between the electric field and the magnetic field. So the electrical energy density and the magnetic energy density is going to be equal. So which option? We can go with the option A as our answer. Simple, dimple, right? Any doubts? Anyone in the classroom? Or is it a yes? Or is it a thumbs up for the next question? Tell me, everyone. Okay, so I'm going to think that it's a yes from everyone as I'm not getting any responses. So moving for the next question, what does it talks about? The electric field associated with an electromagnetic wave in a vacuum is given by the electric field is equal to 40, the maximum value of electric field E naught cos it moves in the z-axis. The z correspond to the coordinate along which this electromagnetic wave moves. K is the wave number, right? In minus omega into t because whatever is the coefficient of time that will be omega. The question is what is the value for this k? Okay, wave vector or you can call it as the wave number, right? Okay, how will you make the calculation? It is if you have the knowledge of 11th standard also from waves chapter, this question can be done because you have to know the simple relationship that the velocity with which any wave moves is equal to the omega value divided by k. The angular velocity by wave number is equal to velocity with which it moves, right? What is the velocity with which an electromagnetic wave moves or electric field which is a part of electromagnetic moves? That is equal to 3 into 10 power 8. 3 into 10 power 8 is equal to omega, whatever is the coefficient of time. That is 6 into 10 power 8, right? Divided by k. So the value for k is equal to how much? 10 power 8, 10 power 8 get cancelled. 6 by 3, that's 2. Is it clear? So which option? It is going to be option B, which is 2 meter inverse. Simple, simple, isn't it? Any doubts you have, please let me know. Every one of you, because I want every one of you to leave the classroom with a smiling face. Okay, so I'm going to think yes, everyone have got it, no more doubts. So moving to the next question. Okay, now let's say that there is a line of separation between the medium. The EM wave was traveling in air and it is entering into another medium. Okay, so it is entering into another medium. This is what the question says. The equation for electric field in air is this. The equation for electric field when it is traveling through the medium is given as E2. Equations are given. Now, it tells that the medium is non-magnetic, which means just like the air, okay, this medium is also non-magnetic, which means whatever is the value for mu, which is permeability. Permeability corresponds to the magnetic properties of the medium, right? So the magnetic property, which is mu, is going to be a constant for the air and for the medium also. Let's say it is mu. Okay. Now it is going to be having a permittivity, which is epsilon as epsilon 1 here and epsilon as epsilon 2 here. Okay. Now, this is not the question which is being asked or which is asked to be found out. We are asked to be found out ER1 and ER2. What is it? Relative permittivity. How is the calculation of that? I hope you know the if E is the permittivity of the given medium and E naught is the permittivity of the vacuum, the ratio of this is relative permittivity, right? Okay, so ER1 can be written as, let me write on the top. So ER1, the relative permittivity in air is equal to permittivity of the medium, which is air divided by permittivity of vacuum. So similarly, ER2, so let's write as E1, right? E1 for the permittivity of air. ER2 is equal to, what is it? The permittivity of the second medium divided by permittivity of vacuum. So ER1 and ER2, that ratio has to be found out. How can we find this out? Any idea? Start thinking, everyone. Okay. Okay. Now let us start doing it. For this, you have to know one more equation, that the velocity of the electromagnetic wave is given with the formula of root of permeability into the permittivity of the given medium. So if V1 is the velocity of the electromagnetic wave in air, that is equal to mu, it's a constant like we already have discussed, into permittivity E1, right? And V2 will be equal to 1 by root of mu into E2. Okay, is it clear till this part? Everyone is targeting for both. Yes, don't worry, we are going to start with the both series. Don't worry at all. We're going to start soon. Okay, now everyone concentrate here. So V1 divided by, okay, V1 divided by V2 is equal to, epsilon is cancelled, root of epsilon 2 divided by epsilon 1. Okay, now epsilon 2 is equal to ER2 into epsilon naught, right? Okay, so I think it is not visible. So 1 minute. Let me start writing it here. Okay, I hope it's fine for everyone. So V1 by V2 is what I was writing. V1 by V2 is equal to, E2 can be written as ER2 into epsilon naught. So ER2 into epsilon naught by E1 is equal to how much? ER1 by epsilon naught. So with a root, epsilon naught cancel, that is a root of ER2 divided by ER1. And what is V1? That's the velocity of light in where? In air. You know that, that is C. What is C? That is equal to 3 into 10 power 8. Now you have to find out the velocity in the medium, which is equal to V2. For that you have to use the formula of omega by K. Okay. So what is the omega value in the second medium? Omega value is equal to K into C, right? Because whatever is the coefficient of time, that is equal to K into C, as you can see that Kc divided by, okay, K value is the coefficient of Z direction, that is 2K. So Kk divides, cancels, and it's C by 2. Yes, any doubt? So the velocity in the second medium is coming as C by 2. C cancel. If you just square it, 4 is equal to ER2 divided by ER1. We want ER1 by ER2. So just change that on the left hand side also, that is 1 by 4. Which option? The option is C. Okay, all these topics are there for board also present now. Okay, so whatever we are discussing here, it is most of the topics and concepts are mainly based on which one? Mainly based on our NCERT only. So whatever we discuss here, it is totally helpful for you for the application and for your learning for the board exam also. Now everyone tell me, is it clear till this part? Everyone in the classroom? Is it clear without having any doubts? I'm gonna think so, right? If you love the session and if you have understood all the concept, what do you have to do? You just have to do very three things, okay? Very three basic things, right? And it's very small thing also. For everything what we do, we are simply asking for from you to do these three things. Just move your cursor, click on the like button. Now itself. And if you think that your friends are also going to get benefited, ask them to come here, okay? So you can share the video. And subscription, I think I don't have to tell you again, right? Why you have to do the subscription? Because you don't want to miss any of the classes, whatever is happening here in the channel. So yes, so do subscribe, okay? And what do you have to do? Yes, do the subscription and get the notification from the channel whenever a new video is coming up, when a new when a new lesson is being taught. So I'm going to leave every one of you for this evening, and let's meet with a new chapter of ray optics in the next class. Till then, bye bye everyone. Take care and good night.